Welcome to the Deep Dive. Today we're tackling a really fascinating book, Ray Kurzweil's The Singularity is Near.
Yep, a journey into a possible future.
Think of this as your quick way to get deeply informed about some pretty revolutionary ideas he lays out.
Exactly. We're going deep into Kurzweil's big predictions, how technology might just transform everything, and, crucially, how fast it could happen.
Right. And our goal isn't just to understand the concepts, though that's important.
No, we want to explore where these things might lead, especially, in terms of future opportunities, maybe even investment angles.
So for you, the learner, wanting to get up to speed, our mission is clear. We want to unpack Kurzweil's main technological forecasts.
Things like AI getting smarter than humans, the amazing potential of nanotechnology.
And that idea of humans and machines merging, we want to give you those aha moments about what could be coming.
And importantly, how this might reshape, well, entire industries and where investment potential might lie.
Okay, so where do we start? Kurzweil has this foundational idea, right?
He does. It underpins pretty much everything else. He calls it the law of accelerating returns. You really have to grasp this first.
Accelerating returns sounds significant. What's the core concept?
The basic idea is that technological progress isn't linear. It's not steady steps. It's exponential,
Meaning?
meaning the rate of progress itself speeds up over time. Think compound interest, but for technology.
Okay, like it feeds on itself.
Exactly.
Hmm.
Kurzweil uses computation as a prime example.
Yeah.
He shows how the price performance, basically how much computing power you get for your money, used to double every few years.
Used to.
Yeah, then it became every 2 years, roughly.
Yeah.
Now, he points to data, like in the Moore's Law,
Yeah.
the fifth paradigm chart in the book, showing it's doubling about annually.
Annually. Wow. So that's the accelerating part in action.
That's it. And that fifth paradigm bit just means we're finding new ways to keep that acceleration going beyond just making transistors smaller on silicon chips.
So it's like a curve getting steeper and steeper, a rocket taking off, not just climbing a hill.
That's a good way to put it.
And crucially, this isn't just about computer chips, is it?
No, not at all. He argues this applies broadly to information-based technologies.
Like what?
Think data storage density, network speeds, even the cost of sequencing a genome. Anything where the core is information processing or manipulation.
Okay.
The better these technologies get, the more powerful the tools we have to design the next generation of technology. It's a positive feedback loop.
Right. So for you listening, the takeaway is that future changes could happen much, much faster than our intuition might suggest.
Absolutely. And that acceleration potentially opens up massive investment opportunities in sectors poised for that kind of exponential growth.
Yeah.
You need to be looking for that curve.
Which leads us neatly into one of the biggest curves he predicts, artificial intelligence. This is where things get really mind-bending.
Definitely. Kurzweil's prediction here is bold, to say the least. He foresees AI eventually matching and then significantly surpassing human intelligence.
And not just in narrow tasks, right? He means across the board.
Yes, pattern recognition, problem solving, creativity, even what we might think of as emotional or moral intelligence, general intelligence.
What's his reasoning for thinking machines can actually surpass us?
A key part is the physical limitations of our biology. Our brains are amazing, but neurons transmit signals relatively slowly, millions of times slower than electronic transistors.
Okay, so there's a hardware speed limit for us.
Pretty much. And our ability to, learn and integrate the sheer volume of human knowledge is also biologically constrained. Non-biological intelligence doesn't have those same inherent limitations. It can scale and network in ways we just can't.
He talks about AI hitting the knee of the curve. What does that signify?
That's the point on an exponential graph where growth suddenly seems to explode upwards. It goes from gradual-looking progress to incredibly rapid advancement. He thinks AI is approaching that point.
Is he talking about the AI we interact with now, like chatbots or recommendation engines, or something else entirely?
He acknowledges the current AI, what he calls narrow AI.
Yeah.
Things like medical image analysis, autopilots, financial trading algorithms, even tools like Spambase he mentions, which uses Bayesian networks to filter spam. These are powerful but specialized.
But that's not the end game.
No. His main prediction focuses on the arrival of strong AI, or artificial general intelligence, AGI. An AI that can reason, learn, and adapt across any domain, just like a human, potentially much better.
And if that happens?
It changes everything. Strong AI would be like an intelligence amplifier for humanity itself, driving innovation at an unimaginable rate across all fields.
So thinking about those fields.
Yeah.
Where could AGI make the biggest waves, and where should someone interested in future investments maybe focus?
Healthcare is a huge one. Imagine AI diagnostics finding diseases years earlier. AI designing personalized drugs in weeks, not decades.
Wow.
Finance, too. Even more sophisticated trading, real-time risk analysis on a global scale, hyper-personalized financial advice. Cybersecurity becomes this constant AI versus AI battle.
Makes sense.
And of course, automation, manufacturing, logistics, transport, even creative industries could be fundamentally transformed.
So investment-wise, we're looking at companies building the core AI.
Yes, the software platforms, the algorithms, but also the specialized hardware needed to run these massive AI models efficiently.
Like what kind of hardware?
Things like neuromorphic computing chips designed to mimic the brain's structure.
Hmm.
That's a really interesting area to watch. The potential there is enormous.
Okay, shifting gears a bit. Let's jump from the world of bits and algorithms to the world of atoms, nanotechnology.
Right, another pillar of his argument.
Kurzweil talks about molecular manufacturing, these tiny assemblers building things atom by atom. It sounds incredible. He even quotes Drexler suggesting costs could plummet to, what, 10 to 50 cents per kilogram?
Yeah, the potential cost implications are just staggering. It almost sounds too good to be true, but the logic is based on precise control at the molecular level.
How would that rewrite economics?
Well, the idea is that if you can build anything precisely from cheap, abundant atoms using nanobots, the value shifts. It's less about the raw materials.
And more about the design,
Yeah,
the instructions.
exactly. The information, the software that tells the assemblers what to build and how to build it, that becomes the primary source of value. The physical stuff becomes almost negligible in cost.
So what are some of the concrete applications he saw for this, beyond just cheap goods?
Medicine is probably the most profound area he discusses.
How so?
Think nanoparticles designed to target specific cells, like delivering chemotherapy directly to a tumor while ignoring healthy cells.
Targeted delivery.
Right. Or nanobots, small enough to cross the blood-brain barrier to treat neurological diseases. He mentions things like nanoscaffolds to help regrow tissues or even organs.
Regenerative medicine boosted by nanotech.
Precisely. And implantable devices, like the artificial pancreas project he mentions. Also using nanoparticles as tags for ultra-sensitive diagnostic tests. He cites real examples too, like a nanopill from McGill University, or nanocages for drug delivery developed in Japan.
So this isn't just theory. There was real work heading in this direction even then.
Absolutely. It points towards a future of radically improved healthcare, maybe even tackling aging itself.
Which again brings us back to investment. What opportunities might emerge from this nanotech revolution?
Well, nanomedicine is the obvious one. The companies developing these targeted therapies, the diagnostic tools, the tissue engineering platforms.
Beyond medicine.
Sure. Advanced materials development, creating materials with entirely new properties because we can structure them at the nanoscale. And of course, the companies building the tools themselves, the nano manufacturing technology needed to make all this possible. It's a potentially vast landscape.
Okay, this next one might be the most challenging or transformative prediction, human-machine integration.
Yeah, the merging of biological and non-biological intelligence.
He talks about augmenting our brains directly, using nanobots, maybe starting around the 2030s.
That's the kind of time frame he speculated about. Imagine nanobots in your bloodstream, interfacing with your neurons, connecting your brain directly to the cloud or to other brains.
Connecting brains directly, wirelessly.
That's part of the vision. Enhancing memory, boosting pattern recognition skills, essentially amplifying our own cognitive abilities with computational resources.
That really pushes the definition of human, doesn't it? What's the ultimate trajectory here?
Kurzweil suggests that as non-biological intelligence continues its exponential climb, it will inevitably become the dominant portion of intelligence on the planet. Our biological thinking will be a smaller and smaller fraction.
So we become mostly machine.
He even talks about version 3.0 human bodies, basically moving beyond our fixed biological forms,
Yeah.
being able to radically modify our physical selves, maybe even upload our consciousness, blurring the lines between physical reality and virtual reality.
Okay, that's deep and profound. What are the potential investment areas connected to this vision? It sounds very futuristic.
It does, but the groundwork is being laid now. Neurotechnology is key companies developing brain-computer interfaces, or BCIs.
Like Neuralink and others.
Exactly. Technologies aimed at cognitive enhancement, advanced prosthetics that feel and function like real limbs by connecting to the nervous system. and also the underlying infrastructure needed to support all this data flow and integration. It's a long-term play, but the potential is immense.
A crucial point Kurzweil makes is that these technologies, AI, nanotech, and biotech, or GNR as he calls them, they aren't developing in isolation.
No, absolutely not. He emphasizes their convergence. They enable each other.
How so?
Well, think about it. AI can massively accelerate the discovery and design of new nanomaterials or complex biological interventions.
Okay.
And nanotechnology provides the tools for more precise interaction with biological systems, like targeted drug delivery or neural interfaces. Progress in one area fuels breakthroughs in the others.
So it's a synergistic effect driving things forward even faster.
That's the idea.
Yeah.
This convergence is what really powers the acceleration towards what he calls the singularity.
Which means, from an investment perspective, maybe the biggest opportunities are at the intersections.
That's a very good way to think about it. Companies leveraging AI for nanomedicine, or using nanotech to enhance genetic therapies, or combining AI and biotech for radically new diagnostics. Those intersections could be where the most disruptive innovations occur.
Okay, so let's try and synthesize this. Based on Kurzweil's roadmap accelerating returns, AI, nanotech, biotech, convergence, what are the key emerging sectors and maybe specific opportunities that align with this vision?
All right, summarizing the potential growth areas we've touched on, definitely ongoing AI development, both software and that specialized hardware like neuromorphic chips, nanomaterials, and the whole field of nanomanufacturing. Biotechnology is huge, especially areas like gene therapy, RNA interference, that's RNAi, for silencing genes and significantly reversing aging. He mentions Aubrey de Grey's SENS approach, engineered negligible senescence.
Extending healthy lifespan, basically.
Exactly. Then there's neurotechnology and BCIs, which we just discussed. Personalized medicine driven by AI analyzing genomic data and nanotech diagnostics.
Okay.
Also, distributed and renewable energy, where nanotechnology could lead to breakthroughs in efficiency for solar cells or batteries.
Interesting link.
And finally, looking further out, advanced computing itself, quantum computing, maybe spintronics, which uses electron spin. He even mentions an example using silicon doped with iron and cobalt for semiconductor spintronics. The tools enabling the future will also be key investment areas.
It's an almost overwhelming vision of transformation, but Kurzweil does acknowledge criticisms and potential hurdles, doesn't he? It's not presented as inevitable.
No, he does address potential roadblocks. There are philosophical arguments, like the Church-Turing thesis regarding computation limits, or the whole question of whether machines can truly be conscious.
The hard problem of consciousness.
Right. And practical concerns, too. The sheer complexity means high failure rates are possible. Safety is a massive issue. Plus, societal challenges.
Like?
The risk of a widening rich-poor divide if these enhancements aren't accessible. How governments might try to regulate or even stifle progress. The fact that our social institutions adapt much more slowly than technology does. He even touches on potential conflicts with theism or holistic worldviews.
These are really important points for anyone thinking about this future, especially if you're considering investments. These challenges could be major disruptors.
Absolutely. They represent risks in areas where things might not go according to Kurzweil's timeline, or could even go wrong. While his vision is compelling, the future isn't predetermined.
So caution is advised.
Definitely. Investing in these frontier technologies involves significant risk. It's crucial for you to stay informed, watch how these challenges are being addressed, monitor the actual pace of progress, and be ready to adapt your strategies.
Does he say anything about the overall economic impact?
He generally believes the underlying exponential trends will create a powerful long-term economic updraft, especially as the market starts to truly recognize and price in this accelerating technological progress. But again, with caveats about potential volatility and disruption along the way.
Okay, so let's try to wrap this up. We've taken a really deep dive into Ray Kurzweil's The Singularity is Near. We focused on that core concept of accelerating returns.
And how that drives his predictions for AI surpassing human intelligence, nanotechnology revolutionizing materials, and medicine.
And the increasing integration, the merger of humans and machines.
And woven through that, we've pulled out potential investment insights highlighting emerging sectors like advanced AI, nanomedicine, biotech focused on longevity, neurotech.
And stressing the importance of that convergence between these powerful technologies, looking for opportunities at the intersection.
Right. It's about understanding the underlying exponential trends.
It's definitely a lot to think about. Kurzweil paints a picture of potentially profound, deeply disruptive change in the coming decades. His book offers one framework, a very ambitious one, for trying to grasp those possibilities.
It certainly does. And as you, the learner, reflect on all this, perhaps it leaves us with a final provocative thought to consider.
Go on.
How will this accelerating convergence of our biology with ever more powerful technology redefine not just our industries, not just our lives, but our fundamental understanding of investment itself and where value will truly be created in the decades ahead?